Alright, we are moving on to explore on the applications of integration. Now in the real world, there are many fields that make use of integration. And if you want me to give an example of such application, it will be the area under the speed time graph, which gives you the distance traveled by the object. So in this particular section, we are looking at area between the curve and the x or the y-axis. So we'll first look at the area between the curve and the x-axis. For a region R above the x-axis, enclosed by the curve y equals fx, the x-axis, and the lines x equals to a and x equals to b, the area of region R, which is essentially this region shaded, will be equivalent to integral of from a to b of y dx, which is equivalent to integration from a to b of fx dx. So take note that the function fx has to be at least 0. Now we move on to page 13 to look at example 5 to further strengthen our understanding of area under a graph. Example 5 says this: find the exact area bounded by the axis, the curve y equals to e to the power of x, and the line x equals 2. So before even solving this question, we have to have a diagram to allow us to actually see how the graph looks like. So based on our understanding from O level, we should know that e to the power of x looks like this. So since we want the exact area bounded by the axis, the curve, and the line x equals to 2, essentially we want to find what is the exact area of this shaded region. So to find the area of this shaded region, all I need to do is to integrate from 0 to 2 of ex. So it turns out that we will have this answer here. And substituting the value of 2 minus the case when substituting the value of 0, we'll end up having e squared minus e to the power of 0, which gives us this answer. So sometimes it's good to check whether our answer is correct by using a GC. So all we need to do is to key in the function e to the power of x, e to the power of x, and we need to graph it out. And the question asks us to find the area under the graph from 0 to 2. So what I'm going to do is to call the function secant calculate, go to number 7, where you see this integration of fx dx. Lower limit 0, upper limit 2, and this is the area under the graph, 6.389. So what we can do now is just to do a quick check. Is this value 6.389? So use your calculator to find out, and in fact yes, the answer is approximately 6.389.